boards. There we go. Now we're officially on the record.
Cool. I like that. The tattoo is good. I don't know what it means, but it looks cool.
It is from, there we go.
I can see it.
Nope. There we go. It's from G.I. Joe's.
Okay, cool. That makes sense.
Snake Eyes and Storm Shadow were my two favorite characters, and they were both ninja from the same ninja clan. Well, it turns out that the G.I. Joe artists stole it from the I Ching. So now I have...
I figured they were I Ching.
Yeah.
What do they call them?
Trigrams.
Yeah.
Now I have just a whole bunch of hippies being like, hey, bro, what trigram is that? It's like, son of a bitch. Yeah. That's not it, but it's the 63rd. So...
Sounds... Someone at Tlon's been reading the I Ching I was just talking about, so maybe that's part of why it's on my mind.
Yeah, it's a cool reading system. I specialize in tattoos that confuse people, because this one is for martial arts, and it's also the secret symbol for Alcoholics Anonymous, which I didn't know for 8 months after I got it. I just had really weird conversations with people at airports.
Yeah, or like at the bar.
Yeah, like I would get done with the show, and then I would go to the hotel bar, and then I'd be like, yeah, I'll take a Miller Lite or whatever. And the guy was like, are you sure? It's like, is there something wrong with the tap or what? And he was like, no, just wondering. He thought he was just watching somebody falling off the wagon.
Yeah.
I was totally missing all those cues. So yeah. Fun times.
I mean, it looks cool. I wouldn't have known, so yeah.
Thanks. Yeah, and a comedian buddy of mine, he was like, no, you just need to say that this is the food pyramid and alcohol goes with everything.
It's also true.
Yeah, I bought that joke for $7 off of him. I was like, I'm going to wind up using that for the rest of my life. It's worth all the money in my wallet, $7. There you go.
Is that a thing? Do comedians buy jokes from each other?
Absolutely, because a comedian might come up with something just hilarious, but it would never fit their character or a show. And they go, well, this absolutely filthy thing would fit you. So here's a joke, right?
Got it. That makes sense.
Not also happens in the magic world too. Like Chris Angel takes a lifetime to become Chris Angel, get his first TV special. That monster devours his lifetime's work in an hour.
Yeah.
And then the production company goes, hey, let's do this next year. Like, how are you going to get a lifetime's worth of experience, farm it out to the consultants? Yeah. Super weird.
I mean, it's nice that there's some, like, I don't know. Yeah. That people actually, I mean, it's like an NFT or something, like NFTs that go with like art, right? It's like, you're like, well, it's just a JPEG, but it's more about the honor system or something. Like, it's nice whoever owns the, right to it actually keeps it or whatever. I don't know.
Exactly. That's not a bad idea, is to just tag each joke to an asset. And now it's on the blockchain of who created the joke first.
Actually, yeah, there's something to that. You could, I mean, I guess maybe that's actually kind of the idea. I sort of struggle with like art NFTs, but
I have a whole primer on that. Primer, however you say that. Basically all of what I write, I sit down and go, I need to explain this to my mom. and then I write my article. Then everybody goes, boy, this is really easy to read. So yeah, it's helping people redefine what ownership means of artwork. And artwork requires provenance of, well, who owned this before me, as a signal of how much I can trust whether this is the real deal or not. Mm-hmm. And provenance protects the investor from the artist creating two of something and selling both as one-offs. Mm-hmm. So the NFT solves that. It's like, you can download the image of of Mona Lisa right now, you're still not going to own it, even though you possess the image. So the NFT is its metadata along with the image. It's just more dimensions to the artwork than the JPEG itself. So anybody can download the JPEG, that's cool, but you know you're not the owner until that NFT is in your wallet.
Yeah.
And kind of in a way, ownership is who can give it away.
Yeah. Or sell it. Yeah.
Right, right. Because if you can't give it away, you can't sell it, you don't own it. So if it's not in your wallet, not yours. Just
It's
kind of
still
weird.
kind of an abstraction.
Oh yeah. Yeah, it's really weird and out there. It just keeps getting more and more abstract from reality. It's just kind of getting distilled to its essence until it's just an idea backed with math. And you're like, yeah, that's art.
Right. Sure.
Very, very strange. So yeah,
Uh,
well, our levels sound good.
okay, good. Yeah, I was gonna say, I was like, don't, you can drive, man. Like,
Right
I
on.
don't know what you
So yeah,
want to talk about, but
basic thing is that I'm open through like the next hour and 20-ish minutes. If you've got to
sure.
go at a hard stop, totally cool. You're in the driver's seat for when we pull the plug.
Yeah,
And anything other than that, well, I like approaching these as an idiot and asking you really dumb questions so that we
sure.
can get smart answers. But to kick off, just introduce yourself. That way it's done perfect, and we'll take it from there.
Okay, sounds good. Yeah, I have about an hour, I think. I don't actually have something scheduled, but someone was just right before this started was texting me being like, wait, let's talk about this thing. So
Cool.
yeah, just call it an hour, but whatever. Honestly, by that hour, we're going to run out of things to talk about. Probably. I'm not that interesting. Anyway, assuming you're going to edit this. I'm Galen. I run Tlon, which is a company that works on Urbit. People always ask me to introduce myself in different ways. It's like I can talk about myself or I can talk about what I actually do. I guess the really broad answer is that like I have kind of a mix of a design background and a technology background. And then, yeah, I work on sort of technology projects that I think of in a broader sort of cultural aesthetic context, maybe about how people use them and how it changes the way that they think and build communities and stuff. And so, yeah, we can kind of dive down either side of that.
Yeah, both I like, which is kind of picking your brain about how you got to be you, and that helps folks appreciate the context of the projects that you're spending your life building and
Sure.
why you think they're important. So, if you've got a design background, how did you land in that? Did you have awesome/horrible parents like mine who said you can do whatever you want? You want to be an artist, go for it. And then I just took that and ran. That's my degree is in painting. So
Oh, cool.
when
I didn't know
people
that.
know, oh, you're a performer, what did you get a degree in like finance as a fallback? I'm like, nope, painting. I
Yeah.
was like, I went all in. So what
Yeah.
was your background there?
I guess I probably did have somewhat similar parents. And I do kind of feel like it's like makes sense. My dad's a scientist and my mom is like a sort of like movement teacher. And so it's like these two sides of like sort of, yeah, my mom's definitely the more out there creative one. My dad's like a kind of a nerd in a good way. And yeah, I don't know. I mean, I think, and then I was just exposed to and just fascinated by computers at a really young age as this way that you could make stuff and kind of like, yeah, I was never that interested actually in some ways in like totally, I loved to draw as a kid, but I don't know if I ever got as into like really unconstrained ways of making things. I was always kind of interested in like how to either start by building a system and then working within that system, or like taking some existing system and like working on that. And that was probably true long before I went to architecture school. But I think in many ways, I probably think of myself more as an architect or working in the kind of like discipline in the longest form sense. The things that fascinated me in school were much more like ancient architecture, much more than like modern architecture. because I think originally architects really thought about, like, the architect was the person who, everyone's wandering out across the plane, and the architect's the person who's like, this is where we build. It's more a recognition than it is like a, how do you build like the facade of a building or whatever, which interests me very little.
Right. And it is working within those constraints of physical reality. It's the vision of, here's a thing that doesn't exist that we could make real, bounded by the laws of the universe.
Yeah.
So working with imagination and engineering, you create something pretty cool.
Yeah. So like, I think of fine artists, like the best fine artists are able to, in some ways, maybe they're at the very edge of the zeitgeist. Like they're trying to show you what's possible. That I think of architects as being sort of like, they can understand what might be possible, but they also have to have some practical ability to actually realize that vision or figure. It's also a lot of it's just about figuring out how to actually get it made, get it built. So that's why architects, often like spend a lot of time on building technology in whatever period of history, or even the technology of drawing, because you need to be able to like actually concretely imagine things that are buildable. And I think now, like, a lot of that is basically software. I kind of think eventually, like, the education of an architect will include computing systems, because computer systems like shape the way that we think and the way that buildings used to. And it's the same type of thing. You have this nice feedback loop, this kind of dialogue that goes on right between like what's possible with the technology that we have, what should be possible, and like how can we get something done in like a reasonable time frame.
Right. Well, one thing that's always really weirded me out about architecture is how much time is spent building something that isn't there. It's defining it's the walls are defining the usable space for the humans to walk around and move in. So it's kind of like the stuff that isn't built is more important, because that's the functional part created by the boundaries dreamt up by the architect.
Yep. Yeah, so that's definitely right. And one of the hardest things to understand, I think, like in practice, meaning like, architects think in voids, right? Like you're thinking about the thing that isn't this emptiness. You're trying to create empty space where things can happen in some sort of open-ended way. And most really successful, certainly long-lasting works of architecture at whatever scale are ones that they have to be inhabited, right? Like a chair anticipates someone sitting in it. It's not actually about the form of the chair. It's about the thing that's not there. And so thinking in that way, this kind of opposite way, right, where you have to like imagine all the possibilities, which can actually be kind of exhausting. I think if you try and think of it actually materially, you're trying to imagine all the possible things that could happen that could sort of drive yourself crazy. You have to learn sort of to think systematically about ways that you can create opportunities for people to be inventive or creative, or to go about, their daily lives, whatever, in emptiness, basically. But I think that's true. Like, there are some artists who like kind of are on the edge of being architects in this way, so like giant Sarah sculptures or something like that, right? They're actually all about how you inhabit them and respond to them, and like what goes on like in reality when you're inside of these big torqued things. Or conversely, it's like, Central Park is like a work of architecture, but it's really just like a giant void. There's nothing there in a way. I mean, of course, it's built as a park, but what's powerful about it is that it's like you're in this giant emptiness inside of a city. It's kind of a weird.
It really is. So when you're not on a podcast, you're maybe at a cocktail party, do you introduce yourself as an artist, a designer, an engineer, an architect, CEO, versus how do you see yourself? Like, how do you frame yourself internally versus presenting to other folks?
It's definitely like one of the great like conflicts for me is like when people are like, what do you do? I'm like, I don't know. Because certainly I think of myself mostly as an architect and operating in sort of almost like it's kind of an academic definition of architecture, of course. But I think of what we make and what we work on as being kind of like long-term historic. Like eventually, I think people will think of this stuff as architecture because it's the same. It just requires the same kind of design thinking. It's like the same discipline. I tend to think like buildings are finished. Like we already know how to build. That's like it's a vocation in a way. Like it's like a known thing. It doesn't have anything to do with like, I don't know, imagining what's possible with how communities might work. But obviously not trying to have that conversation at a cocktail party. So for the most part, people just say like, what do you do? I say, well, I build software. That's actually like not, it's kind of a vague answer. But that's what I usually say.
Nice,
uh,
nice.
And yeah, I think I don't know if that's the answer you were looking for. It depends on
Yeah,
who I'm talking to.
It is, right? Because that's kind of a challenge I face too. And I like to ask almost all my guests that kind of question because of like, all right, how do you put yourself in a box? And for me, I've kind of fallen down the storyteller route because storytelling is architecting the experience of unfolding the right details at the right time in the right way to the right people.
Yeah.
That is systems thinking too.
Yeah.
But in a really weird way. So it's also difficult to get paid as a storyteller.
Indeed, that makes sense to me. I don't think of myself as actually, I think especially, this is really obvious. Well, I think it's almost like a difference in, there's like maybe like a sort of semi-genetic difference between designers, but I think there are designers who are very good at narrative and good at thinking in narratives. And then I think there are designers who are good at thinking in systems. And I actually tend to be the latter, but I think to be successful in building something, you need to have a bit of both. Yeah, but again, most of the time I'm not kind of heading straight to that level of like abstraction about what I do. Well, if someone asks me that in San Francisco, it's like I'm for the most part, I just want to give like a kind of unremarkable answer and like let people dive in. I'm trying to let people, tell themselves their own story or something, right? Like, it's like, if you want to talk about it, we'll talk about it. But if you want to think of me as like a guy who runs a startup, that's fine. Because I actually also like am interested in the kind of operational, like how do you get stuff done and get people to work together and like make an institution work. So yeah, I'm also happy to talk. I often find myself talking about that kind of stuff.
Yeah, for sure, because you are out on the edge there, and part of my background is working at 1871 in Chicago, which is a tech incubator. So there's all sorts of tech entrepreneurs there, and my job there was to show up and just have office hours to help the entrepreneurs communicate their value to the market, which sounds fancy, but really it was helping them stop talking about their features and start talking about benefits.
Yeah.
So that was the easiest thing. So when you're talking about narrative versus systems, I would come in and talk to the systems guys and be like, here's how you tell the story in a way that human beings will be able to understand this. And then watching that light bulb go on was a lot of fun. So I would love to dig into kind of your perspective and mission for making the company successful, and also how you've defined that for yourself, the business, and the future too.
Yeah, that's a big question. So I think that the goal is pretty simple, which is basically just to give people like a really high quality, open-ended, general purpose computing experience. And that I think comes from the fact that there was a lot of, the pioneering work of like just making the PC into something that exists, people can explore. I think of as kind of like the tip of the iceberg that still, then there's so much more possibility there in terms of what you can give people with this very open-ended sort of toolkit. And we're just barely, and then for the most part, the software that we use is not actually really exploring that territory, which I think is very rich in terms of getting people to, kind of both look within themselves in a way, like understand themselves better by making things and by being able to sort of store their data permanently or store their experiences permanently, but also by how they connect with other people and build communities. So like looking outward and actually using networks. And so I think that is in a way a kind of intuitive insight, right? It's like, there's all this potential with computing systems in general, and then you try and take the practical step and say, well, how can we realize that or make that possible for people? But what you're really trying to give them is like a sense of using something that is genuinely like a tool that feels, like people can, kind of write their own narrative into how they compute and how they, carry out their lives in the digital world. So I think of, if we can satisfy that, basically deliver a really good user experience to people, one that they depend on, that they care a lot about, and that like enriches their everyday lives. The nice thing is that the way there's kind of a feedback loop between that and the technology we build, which is that, well, if that thing is actually really useful, then they should buy it and therefore own a piece of this entire system. And the price of address space should basically reflect our ability to build something that's really genuinely useful. That looks a lot like what it was like to build a company when you just sold a physical thing. But of course, we, for the most part, sell digital stuff. So the core mechanic of the company is really simple, I think. There's all kinds of, we can dig into like how we actually go about running that, and there's some somewhat slightly speculative component to it. And there's also the fact that it's a network, it's not a company really. In some way, we're a company, but we're a part of this larger network. That's, I think, a pretty unusual thing that I can't tell you I even fully understand.
Yeah, me either, because that was a really cool detail about computing isn't done yet. Kind of like what you were talking about with architecture. Since the first people walked into a cave and they go, oh, this is useful, this is cool, this can protect us from other elements, this is neat. We've had hundreds of thousands of years worth of practice building things. And through Gothic architecture and barrel vaults, and now we can enclose even more space with less material, to Buckminster Fuller and the geodesic dome. We've been doing more and more with less. And now, kind of like what you're saying, we've pretty much figured it out. Same thing that if we polled most people, I would think they would say the same thing about computers. Because they're like, well, it's Windows and it's Mac. Like, boom, done. Like,
yes, I agree.
You've got your two
they're
computers.
Like, it's done. Yeah.
Right. And then peeking behind that curtain to see just how wacky it actually is and can be, and how little space has been explored in that context. That blew the roof off my mind a couple years ago when I found Urbit. That was my rabbit hole into, computing can be really cool stuff.
Yeah, well, I mean, like the interesting thing about like Windows and Mac, certainly if you just look at like Windows 3.1, original Macintosh or whatever, the Alto, the origins of sort of like desktop computing. Like the desktop computing metaphor is totally just the desk of the 1970s. Like it's totally just the office metaphor turned digital in this very direct way. And we've modified it a little bit. And then we just kind of like shoved the network into that environment, right? Which is literally now when I look at my screen, everything is so contained, it's all contained within a browser. It's like contained and separated in terms of like, they're all browser tabs or they're all apps, but we don't really have, the desktop metaphor is actually really amazing because it's this unifying metaphor by which you can get people to understand sort of the space of computing or what a computer is like and how I can manipulate it in this open-ended way. That was all conceived of just for single player computing. But well, what does that look like for network computing? It's totally unanswered question. And I tend to think of like the Urbit that we have today is like an Apple II, which did not answer that question. It's basically like you put in a floppy disk called Landscape and you can run it. and it does cool stuff, like it connects you over the network in interesting ways, and it kind of hints at what's possible here. But the reality is like we're kind of like, you know, inventing the territory and how to, you know, explore it like at the same time.
Yeah, I think that desktop and reasoning by analogy from base physical layer is super useful because it's what a lot of people are used to. But my desk that is just off camera is not compartmentalized. It is
Yeah,
not separate. I have 11 different projects that are all physically overlapping each other. They are not separate, and I can see all of it at the same time. And to
yeah,
me, that's organized,
yeah,
but it's not distinct, right?
yeah,
But computers are over compartmentalized, and yeah, like
yeah,
the nearest co-computing networked experience that I can think of is like Google Docs.
yeah,
Ooh,
yeah.
neat. Right?
Yeah, we have lots
There's a
of
lot more to
cool,
do there.
I mean, lots of these single purpose applications, obviously lots of even, I mean, we've invented lots of, uh, I mean, it's more like we've come up with a bunch of ideas about how you can interact with people over the network in interesting ways, whether they're on social networks or in productivity software. I mean, even just file sharing and like basic collaboration still like opens up like interesting ways in which there's old like Neil Stephenson quote about how like the two ends of a wire is like a wormhole. I'm botching the quote, but it's basically like, it's like a wormhole because the two ends of a wire are basically like the same place. And so I feel like networked computing kind of like makes it such that at first you were like at your desk, and then you're like all of a sudden like you or your desk and someone else's desk are like in actually they're the same desk, and it's sort of weird, and we're still wrapping our minds around that. But
That's
if you
cool.
generalize that fact across different forms of media, anyway, yeah, there's just like it's a pretty rich territory to imagine how people might, yeah, connect, collaborate, and so on. And the weird thing is we also just like live in this weird situation where we actually, you know, network computing is so exciting that we didn't like, it's not like we were taking our time to get it rolled out. You know, it's like, it's so exciting that we actually paved the whole world with it basically and made everything work, even in these really shitty ways, as quickly as we possibly could, even though it probably all needs to be redone, you know? So it'll be an interesting process,
Yeah,
basically.
because there's such an argument for evolution in that, well, good enough was good enough, and since it was the first iteration, we'll just iterate on that iteration. And now, since the 70s, we have these really weird vestigial nerves that go all over the place. They should go from here to here, 4 inches, but they have to go all the way up and around. Kind of like, there's this weird nerve that giraffes have that go all the way up the neck and back. You're just like, that is the stupidest thing ever. So
Yeah,
we've got a lot of those kinds of network vestigial nerve pathways built into our current infrastructure of how the internet works.
yeah,
And it is such a huge deal that who's going to work on it?
yeah,
Because that really is it's a problem that's as big as the internet. So
yeah.
how are you going to solve that?
Well, like most things, it's just a question of incentive, you know? So like, do people feel compelled to solve that problem? And in some ways, I feel like our challenge at first is to say, so obviously it's like, the Urbit assertion is like, well, you designed it wrong at the outset because yeah, you have everyone going to one server instead of people being able to run their own computers. And if people ran their own computers, the user experience of that is just so much better that it's worth making that switch. So on the one hand, you're just saying, look, that should be good enough on its own that people should just be excited enough about that, that you could make that switch almost just purely as like a product proposition. But I think the way that it gets interesting is, of course, yeah, Urbit is a network in which address space is property. And so you have this, instead of a platform like Windows or or Macintosh, whatever, Apple, those platforms are, the value capture is totally within that one institution. So the idea that you'd say, look, this user experience is better, but if you decide to do it this way, you can share in the value capture because you become a part of the network. It's not our network. then you have the potential to like accelerate or at least distribute the, you know, you have a lot of people who can take on the responsibility or not even necessarily responsibility, just go out and explore what's possible with this thing with the clear incentive that like, if you can come up with interesting, worthwhile things here, you'll also, you know, participate in the upside. So it's sort of a different game. I mean, I can't say we've like succeeded. So, you know, we'll see how it goes.
Yeah,
But
that is
yeah,
a good detail. Like for you, how do you define success? Because a lot of
yeah,
folks are like making $1 million and exiting, or I can
yeah,
work on this until I die.
yeah.
What is success for you and the mission of Tlon do you see as?
Well, we definitely like, we want to make things that I definitely could work on this for the rest of my life. And I love working on it. But I like working on it because people find it useful. So it's like, we want to make things that people actually use and can, you know, put to good use, basically. So, I mean, I suppose we measure our success both in sort of like, you know, the one, you think of it kind of like objectives, and we're always writing OKRs. You're always kind of like trying to say like, okay, I want to go do this thing, but I also want some measure of our success. I think of like, what we want to go and do is deliver a better, you know, experience of personal computing, which in some ways I think we have an idea of what that should feel like, and we can internally evaluate that, and we can talk to people and see how they feel about it. But the result is really like, well, do they pay for it? Like, and are there enough people on the network? Like, you do want the network to be as big as possible, and you want people to actually happily pay you for hosting for an address. Because they are, you know, believe enough in the project experience to actually put some measurable, you know, something on the table, basically. So yeah, you want those things to work, and if those things can't work, I mean, you know, sure, like maybe it's not going to work. So far, so good, but like we'll see what happens.
Right. Now, how in the world did you guys put so many of these pieces together? Because there are so many layers to this that, like for example, the address space.
Yeah.
I own my name on the network, which is the name, is the computer, is the address, the whole 9 yards. And the
Yeah.
big problem is, well, how do I know I'm the one that owns it?
Yeah.
And you guys were or are using Ethereum to tokenize all the addresses that could be possible. So
Yeah.
when most people haven't even heard of what Ethereum is and are
Yeah.
just hopping on the hype train of, oh, I can make money playing with NFTs,
Yeah.
years ago, you guys are already like, oh, we can build it to do this thing to solve this one dimension of an even
Yeah.
bigger project that we're building, and you're making Ethereum work for you instead of just being enamored with the Ethereum platform. So how in the
Yeah.
world do you guys have imaginations that big to think through what most people haven't even understood yet? Like, to me, that's cool stuff.
Well, the key is just to think about it. I think there's, Urbit, so the address space itself is like an old, you know, you think of sort of Curtis's PhD project or whatever, from 2002 to 2013, as being, which included the idea of the address space, although not using Ethereum, as being, you know, there's certainly like a lot of imagination carried over in there. And I think then sort of our collaboration during the time that we worked together, it's like we're both, I think, people who just prefer, like it's easier to think from first principles about something. So basically, like if you can get the structure right and you can focus on like what you're trying to deliver, like what is it that you're actually trying to accomplish, and try and be really clear headed about that. Like imagine what is it that someone should either feel or experience when using a thing, and how should it work. And if you have that like very clearly defined in your mind, you can, it's then easier to start thinking about how do you want to engineer it. So I think you often end up with very complicated systems that are engineered kind of like you're trying to engineer your way out of the woods. You know, it's like you need to like figure out where you want to go and like walk in that direction, instead of, you know, always picking where you're going from where you're standing or something. You know, you need to like go up to the ridge line and look at the terrain and figure out where you want to go. So I guess, yeah, like that is a process of just trying to think about what is it that you're trying to deliver to people, and then focus on the most important, try and figure out what are the most important sort of like, not actually technical, but just like material components that have to exist in order to accomplish that. And so if you think of Urbit as being, okay, you want to get people access to general purpose computing that is networked, then you have two problems. You need everyone to run the same kind of computer because they're all going to be networked. And then you need a way of actually, getting a decentralized network to work. And so you can think of that as basically like, that's the inspiration for Urbit as a containerized, like a single virtual machine that doesn't change. And then you need an address space that is able to sort of decentralize itself. There's a few simple properties where addresses have to have value, and they have to be bundled into blocks because there shouldn't be no one should have too much authority in terms of authenticating new users. That's kind of, Urbit's there's a lot of other engineering work, and it takes a long time to actually go and make that work, but the idea is pretty simple. And I do think it comes from this, it's like be very disciplined about clarify the idea first. Or if you're going to experiment, like make sure what you come up with when you've gone and experimented with something, you don't get too attached to, like be willing to throw it away. I feel like it's like a pretty important part of that process.
Right. Because you guys basically were looking at how everything works forever and then go, yeah, this is wacky. I'm just going to throw all of this away.
Well, like with the address space, the original idea was to self-host it. And, even some of the structural stuff, right? So let's see, like, we changed so many things about that, like things about how the address space accountability work, I think was, changed multiple times. And then originally, yeah, we had all this whole, like basically the certificate signing process was all just going to happen on Urbit itself. This was before Ethereum came along, and then Ethereum came along, and we were like, well, at that time we're like 5 people, or practically just like a research group. They're like, look, this is getting adopted, and we can possibly basically like use them almost like a vendor and outsource this, which is a huge security concern. You want this to actually be secured somehow. And that also has its downsides, because when the minute you have Ethereum as a dependency, now we're also dependent on the gas price and all these other, the dynamics of Ethereum itself, which on balance is probably worth it, but it still can be a pain. And it may end up being that we bring it back in-house eventually. So ultimately, I think it's just about being clear on what we're trying to do, right? Like, what is the structure of the address space? How does that work? Then, how do you implement it? I mean, as long as that first part is clear, the implementation, you can kind of like, it's going to be easier.
Right. Okay. So here's the way that I tend to explain what in the world Urbit is. And then you can pick it apart and help me understand it better, which is basically that the internet is pretty janky, and there's a lot of problems with it for a whole bunch of different places, Facebook, whatever.
Yeah.
Those entities are solving actually really difficult problems, like making sure people know who they're talking to, authenticating this person really is them instead of somebody else. But the problems we experience on those platforms where we gather in digital ways, the problems actually come from the network, not the company or the entity that you're doing your friends' activity stuff on. So in order to solve those platform issues, you need to solve the network issues. And if you want to solve the network issues, you need different protocols. If you need different protocols, you need a new computer. And if you need a new computer, you need a new computing language. So it's just basically going all the way down to the bottom, one step short of you need to go mine your own ore and build your own chips. So when you mentioned a dude, Curtis, that was the guy who kind of dreamt up the beginning operating system and a super small definition of what this new flavor computer would be. And from that small crystal grows out this network that is pretty simple and elegant, that solves a lot of those problems in ways of just avoiding the issues in the first place. So that's who you were referencing, and that's kind of what has been built over time, right?
Yeah. So I think I think many people who work with us on this, myself included in some ways, like Urbit, if you've worked on building networked software as it exists today, or like you've built, conventional software, you have started and you care about compute, general purpose computing basically, or you care about people at all, then you've started probably to invent something like Urbit. You're like, well, it would be better if somehow people could run their own version of this, but like, how do I repurpose the existing software that we would use to run a Facebook or a Twitter or whatever? Like, how do I use that for myself or for me and my friends? And that's a hard problem. The only Curtis was just happened to be, I feel like, the person who was both slightly like sort of crazy enough and then also had the professional background to sort of set him up to do it, because he worked on some of basically the first web browser for mobile phones in like the late 90s. It was kind of one of his main technical project before this. And so I think he was just someone who saw what a nightmare it was to get a bunch of computers on a network to work together. And it was like, okay, this is a very unique and interesting problem, and happened to make enough money doing that he could kind of do an independent PhD and thinking about literally just spending, I think, basically 10 years working on this for fun, which also I think people often overthink this. It's like working on this for fun, like maybe one day a week for quite a lot of that time. Like it wasn't 10 years of tireless work.
Right. He wasn't a hermit in a cave for 10 years straight.
No. It was like, he like had a family and was sort of outside doing other things, and I think a lot of it, like the first something like 4 to 6 years were just spent thinking about what knock, which is the virtual machine, which said, it's 13 lines of code, was just thinking about knock. What is the most minimal definition of general purpose computing that we can never change? And that in itself is more of almost like a math problem than a computer science problem.
That still bent my brain though. Like that's not a small accomplishment from my perspective. Because
it's worth contextualizing though. Knock is not that different than like SKI combinators, or there's plenty of existing work. It's a question of, and knock itself in many ways is meant to be unremarkable. It's just a question of thinking about it in this very particular way, which is quite bold. I think that's sort of like, I think of Urbit, like when I found it in 2013, is mostly it was just very bold. It was like, look, actually you can do this. And no one else was willing to go and try and figure out a practical way to do it. And many people now look at Urbit and they're like, this is crazy. And it's like, yeah, it's crazy. But like, if you had a better idea, I'll be happy to hear it because I don't see any better ideas.
Right. Yeah, because I don't have that computer science background to understand the context of it's not completely unique. To me, part of the thing that was impressive is kind of thinking of it as the universal laws that are governing this whole universe of Urbit, and to do it in a way that fits on that single sheet of paper, where other approaches take hundreds of thousands, if not millions of lines of code to just get going. To do that, I was like
it's a basic design constraint though, right? So this is sort of what I was trying to get to before, which is that if you've spent time building conventional software, you know that it's really just industrial grade software, right? It's like all you know how to do is operate cranes and like cement mixers and like a whole team of 1,000 guys or whatever. It's like all you know how to do is build skyscrapers. That has nothing to do with like building a house out of wood. It's like they're just totally different things. And so they bear, sure, like Urbit still computes any function, like so does, plenty of programming languages that run on top of Unix. But if you're going to build a computer for an individual, like the first thing you have to do is just cut out as many of your dependencies as possible, because a computer for a person should be able to last a really long time. Industrial software, someone can manage that. So when you have a bunch of interlocking dependencies and effectively like what can be really brittle systems that require a lot of attention and maintenance, that's fine because you have a company there to take care of it. But a computer for one person, that's a totally different thing. Like that has to run on its own. It has to require very little maintenance. It has to be, it has to pass a bar of reliability that far surpasses anything that would be built out of this very effectively really kind of janky, mess of code. That can work if people are maintaining it, but it can't work in the context of like someone is using it on their own. So they're just totally different like lineages. Like there's some crossover, but in some ways not really. Urbit is more similar in many ways to a Bitcoin or Ethereum in its spirit, right? Like when you build a blockchain, you can't change the blockchain. Or if you do, yeah, you have to figure out how to get the miners to upgrade. And there's a sort of political component to it too. So Urbit tries to actually do away with that at the computing layer. We have some governance, obviously, at the address space layer, but we say basically, look, knock doesn't need to change ever. We'll see. We'll see. I mean, like, that's the idea.
Yeah, I love how ruthless it is. You just go, there's nothing else here. This is it. This is your toolkit. Do it. And you're like, this is a really weird way of doing it. And you're like, yeah, but it can be done this way. Yeah. And once that's kind of proven, then you go, okay, we proved that. Now we can write code for humans. And then you get into Hoon, the kind of the base layer actual programming language there.
Yeah. So like, I actually think Hoon is genuinely extremely weird and is not meant for most people to program. And that's actually okay, because Hoon is probably more similar to like a C or assembly. It's a very, very dense language that's super expressive, but that means it's like, you can't write it like you would write Python or a kind of like more informal scripting language. I think that the way to think about, or the way that I feel like we need to encourage people to think about Urbit more like, Urbit is basically like a personal database. And you can write, stored procedures, or you can write views or whatever. You can write, code to actually pull data out of that database or figure out how that data goes into that database. It's generally like, that's going to be really, really dense and kind of like mission critical code, right? Like if you screw up the way that your data is stored, like that's a big deal. So I think that like, it's like knock is really this concept of like, kind of like you have a frozen foundation to your computing, and then there's a system on top of it, which effectively is just this personal data store. It's like, don't worry about it. I mean, we can get into it if it's interesting, I think, like, but and of course anyone can program it, and you can move software around the network, and we move data around the network and stuff like that.
Yeah, that's a detail I definitely want to just touch on at least, which is, I'm a painter. I'm a mentalist. I'm a performer. I'm a speaker. I am not a programmer. I don't love math, that kind of thing. I still was able to go through and learn functional Hoon. So I was able to go through it and be able to make things happen. And I'm going to put myself down in the history books as the first person to build a magic trick into the Hoon of a generator that you would have to be able to read the Hoon in order for the trick to work. So that's my claim to fame.
So I do think, so sorry, I don't mean to like, it's important to think of Hoon as just like it's a purpose-built language. It's not like for everyday programming the way JavaScript or Python is. And you can certainly talk to your Urbit using JavaScript or Python. But it's true that actually I tend to think Hoon is like a language for people who haven't really programmed before in some ways. Like the difficult thing, about learning Hoon is like if you know a lot of existing languages, it's going to appear very weird. If you've never programmed before, it's not really actually that weird. It doesn't even really matter.
To me, the way I reasoned by analogy was, okay, there's a bunch of different things on my desk, and I just pick one up and put it next, depending on what the information needs to do or have done to it. And
Yeah.
this little block requires these two things and this third one. And I just looked at it kind of like Legos.
Yeah.
Like they're just
Yeah. Hoon
really
is very,
strict Legos.
yeah, it's mechanical. It's like, I mean, the whole, I do think you could almost build, someone needs to build the, what's the Babbage machine that they end up, the difference engine. Do you know what I'm talking about?
Have no clue. No.
Famously, so Babbage figured out a way that you could build basically a mechanical computing device, I think, that would compute the outputs of any polynomial function. It's a beautiful thing. You can look it up. It's called the difference engine, and people have built different ones. They're incredible. I mean, and I think it was maybe part of what's amazing about it is that it can compute. Is it only, it has some very wide range of different functions that it can compute, but it's a physical thing, right? Anyway, I think you could build a physical Urbit. Like Urbit has this very mechanical quality, right? Everything runs in an event loop. So it's like your Urbit is just like, it gets an event, could come from anywhere. And then it takes the state that you already have and this event and uses this one function effectively to figure out, what the new state is. That's it. Doesn't do anything else. And
To
Hoon
me,
is kind of has
that's
that.
beautiful.
Yeah.
That's the universe.
Yeah, it's very elegant.
The universe
Yeah.
has few parameters, and how it is today is a function of everything it's done up to this point. I just, it makes so much sense.
It's quite elegant. And the nice thing, I think, actually, that's very intuitive for people who haven't really programmed before, but it's very weird. So if you have a lot of experience programming and you're like, oh, how do I understand, whatever this library function in a particular language? I mean, good luck. Like understanding how it's actually handled at the processor level. I mean, it's such an absolute nightmare, especially if you have a bug. New language is a bug in some library function. Figuring out where that is in the compiler, basically descending down that software stack. That software stack is millions of lines deep. It's very, very difficult to understand. Whereas I remember when it's been a long time since I've written Hoon, but in the days when I was still playing more with the system and writing Hoon, the way to learn the language is actually that you can basically go and inspect an individual, whether it's a rune or a function that you've written or whatever it is, and trace everything about what's going on in the whole stack. Meaning when you go and compile this piece of code, show me everything that's happening all the way down to how that rune is unpacked and what goes on in the compiler itself, down to the raw knock that ends up getting spit out. And that's an amazing feeling. That's really, really cool that you can kind of see the whole system instead of just being well, I don't know, I run this thing and something happens, that calls out to Unix and does other stuff that I don't quite get. That's powerful for sure. And yeah, I'm not sure I don't know how many people will end up discovering that fact, but it is really cool.
It is. And that's a big thing that I appreciated about the stuff I learned about it, looking into it as well, saying, look, personal computing is one of the most important things about humanity right now, because computers have freed us up for so much. And this essential piece of our humanity that we call a computer isn't really given a second thought. And to do it in a way where even me can learn to trace that all the way down to its atomic units and actually start to understand what you're looking at, that's phenomenal. Yeah, that is completely remarkable kind of accomplishment.
Maybe natural, right? I tend to think of it basically if you look at the systems, if you go to Rome, Rome itself is this artifact, this giant machine that got people to be able to live together, make decisions, figure out where to go, what to do. And in order for it to survive for a long time and be inhabited by lots of different kinds of people, it has to be built really, really simply, and it has to be modifiable by the people who are depending on it. So I just tend to think of it look, there's no way that Google Docs is still here in 50 years. There's just no way. I mean, sure, maybe it still exists. I guess it could still exist, but there's 100 years, absolutely not. It's just not, it just doesn't make sense. It just doesn't seem likely. It doesn't obey the laws of history, these are super Baroque systems that require a lot of capital and a lot of people to maintain them. That's just not gonna work. And yeah, computing has become as kind of our extended nervous system, relies on network connected computers. Like we've sort of decided that collectively. It just happened on its own. And so in a way, yeah, the Urbit like prompt is like, okay, well, we need infrastructure for that that is built in a kind of like in a way that should last, or that you would expect something that important to be built. I welcome other people to answer that question too, honestly. Like, I don't know if we're necessarily right, but I do think the approach is correct. Yeah, I think that's the main thing. But also, yeah, it's open, you know, anyone can contribute and
Yeah, because
modify.
a lot of how things have been done so far seem to be the way that the network would benefit from the most. So it's a
Yeah,
lot of human effort in service of what's best for this entity.
yeah,
And I think a lot of what makes Urbit strange is it's almost like human beings building tools to serve human beings,
yeah.
and that makes sense, and that looks really weird because we haven't really seen that before.
Is that true? Wait, what do you mean? I mean, people
I
do that
have
all the time. Like, you mean
the
that it's altruistic, or?
No, it's more of like my Urbit is mine, and
Yeah.
it doesn't do things to me that benefit it,
Oh,
like
yeah, yeah.
Twitter showing me an ad in my feed
Yeah,
when
yeah.
I've asked to follow these people, and now Mr. Peanut is in the middle of there going, you should buy some
Yeah,
extra
sure.
salty. Like
Sure.
so that is benefiting the network. That's benefiting the platform in service of it getting something from me. So
Yeah.
my experience isn't what that is designed to focus on.
Yeah,
Whereas
yeah.
the Urbit setup is more of, well, you could build it to do whatever you want.
Yeah.
And it's in service of you, human, not, hey, human, go feed this beast called the internet.
Yeah, but that's like most of, I mean, look, everybody has a job, and at that, and for the most part, you're, you know, sort of in the context of doing your job, you expect that someone may ask you to do something. And this is, I mean, I'm in charge, but this is true for me too. You know, it's like, you're like, look, you have responsibilities that you serve. And the weird thing about the incentive structure of most of our communication tools is that you're actually there to serve, you know, watching enough advertisements to get the info. I mean, forget about their profit margins or whatever. It's like, look, if you want this thing to exist, you need to watch this ad, you know? And I think that's just a question of it's like, well, yeah, that's the way that the incentives work in that system, you know? And if you want to, you know, our approach, I guess, is basically to say, like, we think people want to be able to compute, that they know that it's important and that it's worth paying for. And that if you can give them a good experience of computing and they'll pay for it, then, you know, that the value capture happens very directly, and you don't have to have this this weird, like, yeah, kind of ancillary relationship. The funny thing is that I haven't talked about this for kind of a long time, actually. And I feel like it's just reminding me of, like, even talking about this 3, 4, 5 years ago. I've been working on this for a long time. People definitely thought we were completely insane. They're just like, no one pays for anything. That's impossible. Whereas now I think it does seem totally very, very possible. It's like obviously worth it.
Yeah, that was going to be my next question, which was, yeah, how do you help people understand the cost of using these free setups in
Yeah,
Dynamics, and what kind of person has begun to understand, oh, you know, if I actually buy it and it's mine, that tool comes with the responsibility of owning it, but also I now own it forever,
yeah,
and I'm not beholden to somebody else now. So
yeah.
how has that been going?
Well, at this point, so I've always been someone who doesn't really believe that people en masse make kind of uh, like it's like the rise of Whole Foods exists in my mind because actually, you know, cooking for yourself from something that's fresh, or at least relatively fresh and came from close by, just is a better experience, like tastes better and is better for you than eating conventional food. Actually, they're comparable enough that Whole Foods and Safeway can coexist, right? But like the rise of the organic food trend isn't because people believe, solely because it's like a political act. It's actually just because it's a good experience. And so I tend to think that the same thing will be true for us, which is people are like, look, I am just sick of being kind of like advertised to by the software that I use. And so I want to use something else and I'm willing to pay for it because I know that that experience is actually pretty good. At this point, our problem is more like our ability to onboard people quickly enough and to just satisfy that demand, which we at this point like just can't do. And ideally, we just stay in that position forever, right? I mean, I'm sure that I doubt that will always be true, or I'm sure it'll go up and down. But I think that's like, yeah, it just comes down to like giving people a great experience, I think.
Cool. So the main challenge is being able to help those people who are already there get on board to the extent that they can be using their computer. And one thing I wanted to ask you about is at one level, the hosting seems like a complete abandonment of the ethos of the project.
Yeah.
Because,
yeah.
Hey, I'll host your Urbit for you. But really, it's kind of like I'm your training wheels until you're free enough to own your own and then set you free. So how do you frame that hosting versus the value is in owning your own information and data?
I think there are a lot of analogs. So I would use I would probably personally use hosting. Like I think I'm like I feel like we built this. I mean, it's not so unilateral. There's probably a number of us who feel this way, but basically like, well, let's back up. I'm like meandering. When we host your Urbit, of course, we have to have one of your keys, and so we could potentially have access to it. But in exchange for, the idea is you grant us that because we keep this thing online. We can answer your questions. We can keep it up, and we can run it on extremely reliable infrastructure. The alternative, of course, is that you host yourself. But if you host yourself, you've got to. I mean, Urbit's relatively easy to run yourself, but you do need to make sure this thing is up and online, which is some responsibility. And of course, if you lose it, you lost it. Whereas we can help you custody your keys. So maybe existing examples based like WordPress.com, Coinbase. So anyone can set up a WordPress site. You could do it from a box in your bedroom somehow if you can figure out how to map the IP to or do dynamic DNS or whatever. Versus, it's actually pretty easy to custody your Bitcoin. It's also really risky. So, anyway, the trade-offs are the same for like having someone host your website or someone host your Bitcoin. Pretty easy. If WordPress.com hosts your website, you want to move, no problem. Still WordPress, just download it, move it to your own thing. You have your Bitcoin at Coinbase, just send it to your own Bitcoin wallet on your ledger or whatever, and you've exited. So ease of exit is super important. It doesn't, because exiting hosting is the same thing. You just download a file, you're gone. Thanks for coming. Good luck. We hope you figure out a good self-hosting solution. I think it's the right on-ramp. We want Urbit to be able to generate a network effect where people can easily build communities there. Like onboarding has to be easy enough that you can get your friends on there. And so hosting is just like a no-brainer in that regard. So yeah, it doesn't worry me too much. It's super important that you preserve. I mean, a couple of things. We do make it quite difficult. We should probably write up how we do this. Difficult. We can't really actually access your keys. It's like you have to give us your keys and they're in memory somewhere, but we don't actually have access to them. Like no one here has access to them. There's probably 2 or 3 of us who could, but it would take some doing to get to them, which is sort of the same type of thing in the Coinbase world, right? And so it's important that you trust that your host actually has good practices around that they're not spying on you, that they're not taking advantage of you in whatever way. And then the other part of it is just that ease of exit is very real, that that, well, I can always, if I need to, I can easily get my data back. So I think as long as a host can sort of demonstrate that those things are possible, it's completely fine, and the convenience is totally worth it. The uptime of cloud servers is way better than the one in your bedroom, but it's also amazing that we can have a network where it doesn't matter. You can run it on a Raspberry Pi in your garage. other guy's got it in his bedroom, and it's all the same. It's all, everyone's talking to each other. It doesn't matter.
Yeah, and that's been my experience. I had an old Mac laptop and started mine there, and then thinking about, oh, it's a server. If it's turned off, it can't serve information. If I want to host any kind of group, it should be on 24/7. And then I moved my computer to cloud server, and then it was up 24/7. And then I was like, what, can I host this myself on a Raspberry Pi? Then I brought it back down from the cloud, and it's sitting right over there. So yeah, I've taken that thing all over the place, and it's still working, and it talks to everybody. To me, it's just magic. I love it.
That's great. I'm glad you were able to migrate easily. Hopefully we'll get log rotation in soon, because your event log is probably gigantic, but after that happens, it should be even easier.
Yeah, before the breach, it was something like 36 gigs or something.
That's painful.
Yeah.
You realize your memory image never exceeds 2 gigs.
Right. Yeah, but it's fun. So for the folks who have made it through to this point, and they're like, okay, this is weird enough, I have to find out what in the hell they've been talking about.
Yeah.
Who is it that should come check you out? Where should they go? And we'll put a pin on it that way.
Who is it is a good question. I mean, I think anyone who's looking to explore, new things about how you can communicate in a digital world should check out Urbit broadly. If you're on the more technical end of that spectrum, go to urbit.org, which will kind of introduce you to this weird technology. If you're less technical and you're interested in it, as obviously it's a network, it's social, you can bring your friends there, you can meet the people that are already there. If you don't want to run it yourself, go to tlon.io and get on our wait list, which we're trying to work our way through, but that's where we'll host a node for you, and everything more or less happens in the browser. And then we are sadly still on Twitter, if you just want to kind of follow along. It's the one social media outlet that apparently we can't really give up. So you can find us just as URBIT on Twitter too.
Outstanding. Perfect. That stuck that landing. So yeah, I'll make sure to put it in the show notes and all that jazz. So my goal is to get this out like next, because I've had a whole run of weird episodes. So this one will go out like on Sunday or Monday, and I'll put it into the cycle of shameless self-promotion and in my group too.
Yeah, let me know, and we can like retweet it or whatever. I mean, send it around, certainly put it in the next newsletter.
Awesome. So yeah, on a personal note, like, dude, I love being on Urbit and helping out and doing wacky shit like this. Like, to me,
we'd love to have you.
Yeah, so I have it on my other monitor basically all day, and I've been looking for a way to build a community of awesome people, and Urbit has been the best filter for weeding out the jabronis that I would never want to spend time with. And then boom, here's Urbit. It's like, yes.
Urbit is meant to be everyone's filter, basically. Yeah. Ideally, that's sort of how it grows. But that's awesome. I'm glad you're having a good time, and we're happy to. You're a well-known, you're probably one of our most well-known enthusiasts and sort of advocates, which is awesome.
Thank you. Thanks. So I found my way there by way of Ravencoin, because Ravencoin and being able to tokenize from my phone, I was like, that's kick-ass. And then they were also talking about messaging. And I was like, oh, shit. So if I can create NFTs, send them to cool people, then I can broadcast from there out. But there's no way to come back. I wish there were a better way to build a community. And then Urbit pops up. And I was like...
Cool. I met the Ravencoin guys. I mean, that's how I know John, like Pathfinder or whatever, but not well. Like, we just met at a conference at one point, but I hadn't heard about them until I met them by a pool in Mexico.
That's the way to do it. If you got to meet somebody, that's the way to meet them.
So it was definitely weird. Actually, I met them because he was wearing a Cult of the Dead Cow shirt, which was a hacker collective that I remember when I was from like being a kid. And I think I was the only person at the conference who recognized it. It's speaks to the financialization of crypto, basically.
Oh man, yeah, whippersnappers these days. Oh, never
I
understand.
think of myself as a kid, honestly. Like I just am like, man, I don't know anything. Like why? Anyway, whatever. Yeah, it is weird.
It really, really is. So yeah, awesome. Thanks for your work.
Yeah,
Thanks for being you. Thanks for
my pleasure.
being here. And yeah, I'm looking forward to the future.
It's gonna be exciting. Yeah, thanks for having me, man. I'm glad we made this happen.
Amen. All right, I'll cut you loose, and I'll catch you later.
Sounds good. I'll talk to you soon. See ya.